Okay, we're just going to become better acquainted with the standard normal distribution through something called the empirical rule. The empirical rule for the standard normal distribution. And this is very visual exercise here, and it gives you sort of an intuition for the normal distribution. Now, the empirical rule often has another name, and I'll mention that briefly here in a moment. So as I sort of introduce it, I'll give you the other name. So the empirical rule says, in a standard normal distribution, 68% of the data is within one standard deviation of the mean. 68% of the data is within one standard deviation of the mean. So if we were to look at a picture of this, if we were to look at our standard normal distribution, and our mean is right here at 0 standard deviations, right? If we were to look at that and we measured one standard deviation, so here's positive 1 standard deviation, and over here's negative 1 standard deviation, then the empirical rule says that if I were to look at the data that lives in here, then this right here, all of this would be 68% of your data. Okay? 68% of your data lives within one standard deviation. Now I'm going to go ahead and tell you what another name for the empirical rule might be called sometimes. Sometimes it's called the 68, 95, 99.7 rule. Let me make sure that'll fit on the screen here as I'm recording. I realize it might be cut off. Yeah, let me adjust here a little bit. I think it's right at the top. Okay, good. Now, if that's the case, you can probably guess the last two bullet points here. It means that 68% is within one standard deviation, 95% within 2 standard deviations, and finally 99.7% within 3 standard deviations. And so if we were to look at that over here, if I went out to positive 2 standard deviations and negative 2 standard deviations, then that means that if I looked at all of this, including the 68%, all of this now, all of this together makes up 95% of the data. So when you get out to 2 standard deviations on either side, you're covering almost all of the data. All right? And finally, lastly, if we go out to 3 standard deviations from the mean, we still don't have all of the data. We only have 99.7%. But what that means is, if we look at all the data that lives here, including the previous 2 groups of data, all of that is 99.7%. Now, if you're taking notes, you may want to draw a separate diagram for each of those 3 to kind of see it better. But I just want to get the point across that when you go out to 3 standard deviations, that includes everything that is within 2 standard deviations. All right? Now, this is really useful for us if we're sticking with these whole number standard deviations. And so that's what we're going to focus on here. When you start getting to decimal standard deviations, you need a table to tell you these percentages, okay? So that's a different topic here completely. But this rule helps us develop an intuition for the distribution that we have in a standard normal distribution. So let's do some examples. Let's consider exam scores, let's say. Consider exam scores. How about as follows? So I'll give you a diagram. I'll make it kind of large here. And we will say that the mean exam score is 77%. Okay? And so we've got a mean of 77%. And let's say we have a standard deviation of 8%. Okay? Sorry, that seems a bit high. Let's say a standard deviation of 7%. Let's deal with sevens, okay? So then what we have, if we go one standard deviation above, I would add 7% and I would have 84%. Another standard deviation would be 91%, and another standard deviation would be 98%, okay? Going left, I would get 70%, 63%, and 56%, all right? And so what we've done there is we've sort of identified our data based on how many standard deviations they are from the mean. So this is your 0 standard deviation mark. And then this is +1 standard deviation, +2 standard deviations, and +3 standard deviations. On the other side, we have -1 standard deviation, -2 standard deviations, and -3 standard deviations. So now we can ask lots of interesting questions about this. So maybe question A will ask, what percent of exam scores are between, let's say 63%. What percent of exam scores are between 63% and 91%? Okay? So if we were to look at this, I'm going to redraw kind of small here. I'm interested in going from 63% to 91%, which is exactly 2 standard deviations to the right and 2 standard deviations to the left. So I get this sort of symmetric portion of the curve here. That's the best I can do. I apologize. So we're asking, what's this percentage here? And luckily for us, this is pretty simple because we're going 2 standard deviations to the right and we're also going 2 standard deviations to the left. And the empirical rule says that, well, 95% of your data lives 2 standard deviations out. So the answer here is 95%. You could also say that if you were to take this test based on this data, you would have a 95% chance of scoring between 63 and 91%. You could also think of this as a probability, okay? So that's pretty easy because we went out to 2 standard deviations on either side. Let's ask a slightly different question, slightly harder question. Part B. What percent of exam scores, let's say, what percent of exam scores are below 70%? Okay? Quite a bit harder question. So if we were to look at this now, what percent of exam scores are below 70%? So 70% is below the mean, so it might do this kind of thing. Right? Maybe, so we're wanting all of this. What's this percentage? Now, using the empirical rule directly won't work because 70% goes out to negative 1 standard deviation. So somehow I have to use the 68% mark of the empirical rule because that's the only number I have involves 1 standard deviation. So if I were to continue the curve and go over here to the mean and back down, then my 68% would be between 70 and 84%, right? I didn't draw that very well, sorry. Let's see here. Let's make this better. So the mean would be in between those. There we go. I would know that this right here would be 68%, between 70 and 84%. But this question is asking us what percent lives over here. So here's what we have. If this red region is 68%, right, then everything that's outside of that, namely, I like to maybe call these wings, they're on the outside of this red region in the middle, everything else here has to add up to 100%. So if I want the percentage living in those wings, I would take 100% minus my 68% in the middle, which is going to give me what those have to be, which happens to be 32%. Okay? So this wing, this left wing, and this right wing together make up 32% of the data. But I'm only interested in the left wing, the data that's below 70%. So now I have to divide 32% in half because those are exactly equal to each other. They're perfectly symmetrical, which tells me that the answer to the question is 16% of the exam scores are below 70%. Okay? Also, equivalently, if you were to take this test, you would have a 16% probability of scoring below 70% based on this data. All right, so let's try another one. We'll do one more example. I think this is part C. Sorry if it's not. And let's now look at what percent of exam scores are between two values that are not the same number of standard deviations. That perhaps is the hardest type of question to answer. So what percent of exam scores are between, let's say, 56% and 84%. Okay? So 56% goes out to 3 standard deviations and 84% is up to 1 positive standard deviation. So if I were to look at that, 56% is here, 84% is here. This guy is at +1 standard deviation, and this guy is at -3 standard deviations. So if I were to focus just on that portion, then I would have something like this. Okay, and I'd want to know the percentage of the data that lives within this part of the curve. Now, if I were to continue, clearly I'm going to have to use 2 parts of the empirical rule. The part that goes to 1 standard deviation, the 68%, along with the part that goes to 3 standard deviations, which is the 99.7%. All right, so if I were to look at the 1 standard deviation part, so here's our mean. So let's say that this is -1 standard deviation. Then I would know that this region here is 68%. This part right here is 68%. Okay? Simple, right? Let's expand out to +3 standard deviations. So +3 standard deviations. So I would know that, and by the way, what I'm interested in here, let me keep this in purple, is between the 84% and the 56%. I'm interested in that. So a couple of different things. if I were to look at all of this together, all of the percentage from -3 to +3, well, that's the 99.7%. And what I want is this purple region. Well, if all three pieces make up 99.7%, right, and this makes up 68%, when I subtract 99.7 minus 68, what's going to be left are both wings here. Agreed? I'm going to have both wings. And 99.7 minus 68, let's see, that's 31.7. So 31.7% makes up this wing and this wing all together. Okay, let me move over here. So now we have this wing and this wing. How does that help us? Well, the purple region that we're interested in is the 68% plus the left wing. So to get the answer to this question, we have to know how much one wing is, right? We have to know how much one wing is. So just like before, since we have the percentage of both wings, we need to divide by 2. I should have brought my calculator. 31.7% divided by 2 is 15 plus 0.85. So 15.85%, I think. 15.85% is this one wing here. It's also this wing, but we don't care. We're interested in this wing plus the middle section. So to get the final answer, all we have to do is add those numbers together. And I'm running out of space down here, but 68% plus 15.85% is 83.85%. So all of this is based on this empirical rule, which tells us percentages of data that live within whole number standard deviations of the mean.